Hi everyone, and welcome back to this tutorial on building a Linux from scratch system. Now in the last two videos we have prepared the USB stick and installed some, we partitioned it, installed file systems and created some directories, and then in the last video we've downloaded all these source codes from the list in the Linux from Scratch book. And yeah, now so far this was relatively trivial, and now we want to start really installing this stuff. So what I'm going to do now is I will create subdirectories here for each chapter. Right now we are at the beginning of chapter 5, so I will start with chapter 5. And chapter 6. Chapter 7. Chapter 8. And then I will go to the corresponding parts of the book. Here is chapter 5, and here we have, for example, the binutils package, and then in each of these chapters, so each package has its own chapter, and these chapters then give you some codes telling you how to install these packages and explaining the parameters, and yeah, also explain the package content. So why do you install it? Like binutils contains a linker, an assembler, and some other tools. This is actually, so binutils, this is only pass 1. We will later compile that again, as I told you before. Like here would be pass 2. And I think, yeah. So chapter 8.18 I think is the last time we compile it, and the last time you compile something, that chapter also then contains descriptions of the things that you find in these packages. So like binutils, for example, contains AR, which can create archive files. I think you use them for combining different object files into a library archive. Then LD is the linker, NM and readelf are programs to look into object files. So yeah, let's start doing all that. So in chapter 5, the first thing we need is the program binutils. And then I really want to emphasize, Linux from Scratch advises you not to just copy and paste these instructions. But yeah, as a first approximation, I will just do that. So this is one of these examples that I told you about, where you really just have a configure, make install, and here with some parameters telling it where to put the resulting file and which architecture to build it for, and some other stuff. Yeah, as I said, these parameters are then explained very well in these chapters. For example, here, disable NLS, disabled internationalization, because this is just a temporary tool, so we don't need that fancy stuff. Disable W error. We'll just disable some error messages, or warnings are not gonna become error messages. I personally prefer to use W error because I want my programs to really not even have warnings, and W error is a parameter that really forces you to resolve all warnings, and that's why I personally like W error, but of course people use different versions of these programs, and the developers of binutils, for example, might have not optimized it for our version of GCC or whatever, so you might get some problems, and that's why it really makes sense to disable W error in many cases here. Okay, so this would be the script here. So as I said, we will run this script, and but we will still look at the output of the script, and if something goes wrong, we still have to resolve it. So but we will then resolve it by changing this script. So I think just copy and pasting it, although it's not advised, I still think it makes sense as a first approximation, and then if something goes wrong, then we can look at things and fix things. Good. So what I'm going to do now is I am going to create yet another script. Package install sh. And I think you probably already have a hunch what this is going to do, after I've already created this script here. So from the LFS script, before I forget it, down here where we copy all the scripts to the LFS sources directory, I will also copy all these chapter directories. Okay, good. And then I want to invoke this new script like this. Source package install.sh, and then just give it something like binutils. But I will need another parameter here for to tell it to take the script from chapter 5, because as you've seen, some of these packages will be recompiled again and again in different chapters. So yeah, we really need to have specify here which script to run. Okay. So yeah, this will work a little bit like the download script. because we will again run through this packages CSV. This packages CSV is kind of like a central hub for our scripts here. That's why I actually created this packages CSV in the first place. You know, in the book they give you the location of a text file that contains all the URLs and a text file containing all the MD5 sums, and you could just download that list, stick that into wget, and it would download all these files. And then you could take that list of MD5 sums and stick that into MD5 and check all the packages for the MD5 sums. But I wanted this central packages CSV so that I can, on one hand, use it for downloading stuff, and now use it for coordination of things. Like here, I want to tell it, hey, I want to install binutils. And now this script is supposed to look into this packages CSV and then look at this line. Of course, we've already downloaded the tar.xz file, but this file is supposed to give us for each package name a file name. That's really an important part here, because for the same thing you might have different downloads here. For example, glibc has this tar.xz file, for example, but then also a patch file down here. So or there are some cases like libstdc++, which comes from the GCC package, right? So there is no direct connection between the name of the package and the name of the file that you get. So that's really an important thing. So if I say I want to install GCC, I need it to extract this file, and if I want to install lib standard C++, it needs to unpack the same file. So that's really one major reason why I have this this file here. Okay, so okay, one thing I need to highlight here is that reading this CSV file like this is relatively slow, and that's why I will just put another program in between here. I will just grep for the package name, and so package was the second parameter. And the first parameter was the chapter. Okay, so okay, so I'm gonna just throw out every package or every line that's not for this package that I'm trying to install at this point. And also, as I've shown you, there are sometimes the same package name but different files. but that only happening in cases where you have a patch file. So I will throw out cases where you have okay, I think like this should work. Yeah, this name is actually pointless because we have the package already, version, URL, MD. We don't need the MD5 sum anymore at this point. But the cache file that's the file that we need to extract. And I will also create another variable okay, this is a bit complicated. So the cache file will generally be named something.tar.something, right? gz, xz. I'm sure we have some tar bz somewhere. I don't see one right now, but the point is I want to create a directory name from that by removing this trailing .tar. Whatever. So I'll echo that file name, and then just remove so I'll do a regular expression of whatever string, which I capture in this capture group here with this \open parentheses \close parentheses. That's a capture group that will allow me to then map this string to just the stuff inside that capture group, and then something.tar. Something. Okay. Okay, that's quite complicated. As I told you, this will just recognize anything, in particular the start of the file name. This here will capture it in a capture group that I can then use back here. And then .tar. Whatever, gz, xz, bz, whatever. But this is risky business, so I will just try this. Okay, yeah, that looks good, right? So it preserves the name of the file, the name, the version of the file, but it removes the extension. This is actually something that I kind of dislike in the Linux world, that these .tar something, it's always quite hard to deal with that because you can have dots somewhere as part of your file name, and .tar.gz, for example, it's hard to capture the fact that tar is part of the file extension, right? Normally you would just say that, well, the file extension is the stuff that comes behind the last period sign. So, but then you would have something like foo123.tar as the directory name, and that's not what we want, right? So, okay, whatever. I digress. Good. So this seems to work. So what we can then do is create that directory. And then extract the package file there. Okay, how do we extract? Extracting tar files. I mean, I'm not a huge fan of tar files, as I've already said, because tar is very widely used in the Linux world or in the Unix world, and but not in the Windows world. And I always try to make my programs cross-platform compatible, and since this format isn't used in the Windows world, I tend to package my programs as zip files, so I just don't use tar files much, and that's why I always have problems when I try to tar or untar something, because I never have the correct parameters in my head. But at least I'm not the only one who has that problem. I remember an XKCD comic that pretty much made fun of that problem, that people just never know the parameters of the tar command. Okay, tar extract file $cache file. And where do I extract it? To $name. Okay. Now we have a small problem here, because many of these packages, and I haven't checked if it's the case for all of these. If it's the case for all of these, you could probably just circumvent it. But many of these packages just contain one directory, which then contains all the other files. So if we just extract this, let's see, like binutils contains the directory binutils. So if you extract that, you will have the directory binutils235 / binutils235 / something. And I really want to go into that directory, but the scripts from the Linux from Scratch book usually require you to be in the directory of the source codes. So for these cases where you really have just one directory in your package, I will then just take everything from that directory and move it up one directory. So something like this. So we count, so we list the content of the directory. Wait, we are in the wrong directory for this. I could just change directory into the directory, but some of these scripts will move around inside the directory, so I don't think this is a good idea, because our script might get confused if one of these LFS scripts changes to some subdirectory like the build directory or so. So instead of cd, I will use pushd. So this is a cd, so we are changing into that directory, but we store the old directory on a stack. So after we have finished running the script, we will just pop d and be just where we were before. And that really gets rid of the problem with any change directories inside the script. Okay, so we go into the directory, we create a list of the directory, and if that, then we count the number of entries, and if that is 1, then we will move everything from that subdirectory Okay, so this gives us the name of the subdirectory, and everything in there, this star here, will then be moved to the current directory. Good. Okay, so we have extracted the directory, or we've extracted the package, we've changed into the directory, we've made sure that we will get out properly again. So now we really only need to run the script from that directory. So one thing, I will put a sleep 5 here, because I want just some time before. So after we've compiled something, I really just want to be able to see, okay, we are done with this thing, and now starts the next thing. I'm doing this after doing this echo, so that we can really see what is it doing now. So if we install one package, it will tell us compiling package, done compiling package. And when the next package is then compiled, it will tell us, okay, now I will start compiling the next package, but it will wait for 5 seconds so that we can look at it and see, okay, now this package is done and this one is the next. So that will just give us a good hint at where we are in this whole process. Okay, so okay, $LFS. Although let's just say parent directory, chapter, $chapter, and then the name of the script is just going to be taken from the package. And yeah, I think it's a good idea that if we just store everything, the whole output of the whole process in a log file. So I will just and of course we need to make sure that this directory exists. And I want to be able to abort this whole thing from these scripts. So if that script fails, then I want to abort this whole thing. And this exit would now bypass this popd, so we would end up in the wrong directory. So I will just put another popd here. Okay. And we need to redirect the standard error for this script to standard out, so that both standard out and standard error are logged in this log file. Okay, I think that looks good. So let's try this script. Okay, it's extracting binutils. This doesn't look bad. So this is part of the configure script. That's what the autoconf does. And this looks like it's compiling. Yes. Okay, so this package will take a while. I will fast forward now again. We've already discussed why we need the binutils package, because it contains an assembler, a linker, and some other tools like the tools that combine static libraries from object files. So that's why we have that package. Yeah, as I said, this will take it some time, so I will fast forward now. Okay, so this really looks pretty good. Looks like everything compiled fine. So let's continue. So the next thing that we would need is the first pass of the GCC. Then we will need the Linux API headers, glibc and lib standard C++. So I'm gonna do the same thing, just copy and paste. Now one thing I want to point out, here we have this, the version of the GCC. I will just put $version here because we are coming from this package install where we have set this version. So if we ever change the version, then this script would just break, right? If we changed it in the packages, it would download a different version of that package, but the script would definitely fail because we wouldn't have the matching version here in the script. So I think it just makes sense to take this from that environment variable. Although I think it would be a good idea to export this. I'm not sure. I think because of the way we invoke this with source, I think we don't need to export it, but just to be safe. What am I doing? I was just, this was the wrong script here. I was in lib standard C++. Okay, but lib standard C++ had the same version, right? Because we are pulling it from the same location, so it needs to have the same version anyways. So okay. this is a code for GCC. Again, here we have a fixed version number here. I think it just makes sense to say, I don't know which version we have. I will just take whatever is there and try using it. If it fails, well, then we need to look at it again, but if we have a fixed version and that version doesn't match, then we are guaranteed to fail. So it just makes sense to me to at least try doing something right instead of definitely doing something wrong in that case. Okay, so we are extracting this, and well, then they want to move this directory to MPFR, this one to GMP, and this one to MPC. Yeah, MPFR, GMP, and MPC are libraries used by GCC for different things, like I think MPC is for multi-precision calculations. MPFR is, I think, multi-precision floating points. So I think these all have something to do with floating point calculations. MPFR, GMP, MPC. So these tar commands really try to extract these packages here, and then want to move them into these more standardized directory names. I think since I don't want to use fixed version numbers here, I will just tell it to uninstall directly into MPFR, GMP, and MPC. And yeah, since these tarballs again contain just a single directory that contains everything with these names here, I will just say --strip-components equals 1. That just means remove this first directory from there. Okay. Okay, so now we have done all these scripts. Okay, binutils, GCC, Linux API headers, glibc, and libstandard C++. So I commented out the binutils because this already, we've done this already. So yeah, let's install the next 4 packages. GCC will take a long time again, so I'm gonna fast forward here again now. I mean, we could talk about what GCC is for, but come on, GCC is GCC. It's the GNU compiler collection. This is our C++ compiler and our C compiler. Yeah, it's pretty obvious what this is for. glibc, of course, is a library which all the other programs are gonna link against, because this library is gonna contain the communication with the Linux kernel. So pretty much everything other programs do, like opening files or opening network sockets, works by talking to the glibc and calling functions from glibc, like fopen, fclose, socket, whatever, which then in turn do the system calls to the Linux kernel. So yeah, glibc really is the adapter between the kernel and your programs, which lets your programs just call some function like fopen, and it will take care of how it's done on that system. So yeah, lib standard C++ pretty much does the same thing, just for C++ programs. And Linux API headers, or Linux API headers, of course, they are there for the glibc to know the signatures. So it's for the communication. Yeah, these are really for the glibc to know how to communicate with the kernel. These things are pretty fragile, so I think it's a good thing if you are really pedantic with the version numbers here, but because if anything doesn't fit there, everything will just break. So this is a part of the Linux from scratch where I'd say you should really try to follow their code very closely, but I haven't done that exactly here myself, so who am I to tell you that? And the Linux API headers, of course, these are the headers for a kernel that we aren't even running yet. So it's kind of funny, but these headers tell glibc how to communicate with the kernel that isn't even there yet. But this will later then be used for communicating with the kernel that will then be there. Okay. So that looks pretty good. It looks like everything ran through. Yeah, so I think that's enough for today. This was chapter 5. Next time we will do chapter 6. Maybe even get into the change root environment already. So tune in next time. If you like this video, like it, share it, subscribe, and please turn off your ad blocker while watching these videos. That would help me a lot. And yeah, see you next time. Bye.